Okay, guys, this is lesson 8, and we're going to do things a little bit differently. So we have looked at how to solve quadratics by factoring. We've kind of talked about graphing a little bit. We've solved them with the quadratic formula. Now we're going to solve them by graphing. Okay, so we're going to solve by graphing, and that can be a really helpful tool for you as we move forward with quadratics and we do the test. You can use this method on the test if you want to. So I'm not going to give you notes. We're not going to do a notes page examples that way. What we're going to do is look at the homework. I've got a preview pulled up of your homework assignment. And here you can see it looks just like yours, except it's a preview. And I've also got this graph pulled up. So I'm going to show you how to do these problems on the Desmos calculator, okay? And we're just going to work through your problems. If you want to, you can do a split screen and you can watch the video as you do your Math Excel work, or you can watch the whole video and go back, whatever you want to do. Really, this is just whatever works best for you, okay? And I'm going to do the video using the Desmos calculator because some of you have not picked up your Inspire calculator yet. So I'm going to show you how to do it on the Desmos calculator. That's going to be your required video. And then I will make a separate video showing you how to find some of the same stuff in the TI Inspire graph or calculator, and that'll also be really easy. It'll be very, very similar, okay? So let's get started. So question number 1, it says the area in square feet of a rectangular field is x squared minus 110x plus 2800. The width in feet is x minus 40. What's the length in feet? So we're just going to go over here to the Desmos calculator, and we're going to type in y equals x squared minus 110x, and then plus 2800. And we see we have our graph here. If you want to zoom out, you can. As you can see, it's a nice quadratic, a nice parabola. I'm going to zoom back in. So if you look at your intercepts, okay, because we said that when we solve a quadratic, we're looking for those zeros, those x-intercepts, those roots, all right? So here they are on the graph. So here's 40. So it said our width is x minus 40. So that takes care of one of them. The other one is 70. So our length in feet would be x minus 70. Okay, so we just did it with the graph. Okay, number 2, a smoke jumper jumps from a plane that's 1,800 feet above the ground. The function h equals negative 16t squared plus 1,800 gives the jumper's height in feet during the free fall at t seconds. So here we're using t and h. T is time, h is height. We're going to change those, and we're going to use y and x. Just because the Desmos calculator, that's what it's wanting. It's wanting the x and the y, okay? So we're going to type that in. So h equals negative 16t squared plus 1,800, okay? Now, part A. How long is the jumper in free fall if the parachute opens at 1,000 feet? So feet is talking about height. So we're going to change that h to 1,000. We're going to change that t to x, okay? And so how long is the jumper in free fall? So our t is our x, so we can look, and here it's 7.071. It says round to 2 decimal places. So 7.07 is our answer. Now, time cannot be negative, so we're not going to look at this negative side of the graph because time can only be positive. So we're going to look at the positive side, okay, the positive x's. All right, it asks us the same thing if the parachute opens at 9:30. So we're going to change that 1,000 to 9:30 and see what we get. Okay, we're still just looking at the positive side because time can only be positive, and we have 7.374. So that rounds to 7.37, and there you go. All right, a reasonable domain for the function h. So we're going to take this 930 back out and we're going to put in y. Okay, so here's our original function, our original quadratic, and it wants to know the domain. So the domain is our x values. It's left and right. So if you look, it's going from negative 10 to positive 10-ish. And so which one of those matches? Okay, it's obviously going to be C, okay, because that's the closest. Now, it's not right on it, but it's the most reasonable. So that doesn't mean the exact domain. It's the most reasonable, okay? And you can also think about it without looking at the graph. That 1800 is referring to our height, and then time can't be negative. So that can eliminate A, okay? It can't be all real numbers, again, because we can't have negatives, all right? Or actually, sorry, I misspoke earlier. It's D. We can narrow out C because time can't be negative. So that leaves us between B and D. B, again, that 1800 is referring to the height, so that doesn't really make any sense. But if you look at the graph, the domain, it's going from negative 10 to 10, and if we ignore that negative side, we have that positive 10. Okay, so the domain is really between 0 and 10 because we're talking about time. Okay, and then let's see, does it let me choose that? Oh, there we go. Check answer. And then we have one more part. And so what's the reasonable? There we go. The reasonable range. So if you look at your graph, okay, I have to zoom out a lot, and you can drag the graph over. So if you look at the top of your graph, it's 1800, okay? And we can also get that for if we think about the vertex is 0, 1800, so that height, that largest y value is 1800. You can also think about it if it's negative, our parabola is opening down, and so the vertex is our maximum, it's our highest point, so that 1800 is our range. And again, if we're thinking about the scenario, we're talking about from the ground up. So we can't go into the negatives because you're not going to go below the ground, right? You're going to stop at 0. So your height can only go from 0 to that maximum 1800. And again, that 10 was referring to the time. So we know 1800 has to do with the height, 10 has to do with the time. So that can help you narrow out some options as well. Okay, your next one, your class is selling boxes of flower seeds as a fundraiser. The total profit, P, depends on the amount, X, that your class charges for each box of seeds. And then you're given the equation, and it models the profit of the fundraiser. What's the smallest amount in dollars that you can charge and make a profit of at least $361? Okay, so we're going to start by just typing in this equation. So we have y equals negative 0.5x squared plus 36x minus 233. Now, the profit needs to be at least $361. So y, or P, is our profit. So we could have 361 there. Okay, and if you look at the graph, okay, it should give you a parabola. Okay, so we have the parabola, and you have two X-intercepts. So you can click on the graph. It'll show you your two X-intercepts. And so that means that we're going to hit this profit twice. And so it wants to know the smallest amount you can charge for each box. So you're going to go to the smaller of the two intercepts. So we have 25.608, and we're rounding to the nearest cent. So that would be 25.61. Okay? And that was it. That was all you had to do. All right, so number 4, we're given the problem: if a certain cannon is fired from a height of 9.8 meters above the ground at a certain angle, the height of the cannonball above the ground h in meters at time t in seconds is found by the function. Okay, and it wants you to find the time it takes for the cannonball to strike the ground. So again, we're just going to type this in, but we're going to use x and y. So y equals negative 4.9, or x squared. Oh, and let's see, can I get my keyboard back? Oh, there we go. For x squared plus 24.5 x plus, oh, x plus 9.8. And there is our parabola. And I'm going to zoom in and drag it down here so I can just see it a little bit better. And so it wants to know when the cannonball will strike the ground. So if you look, it's going to strike the ground at 0, so it's going to be this x-intercept over here, and it's 5.372. So round to the nearest hundredth. So what did we say it was? 5.37? 0.37. Okay. And the next one, very, very similar. We can just go ahead and type in that function, negative 0.01 x squared, and then plus 0.6x plus 6.2. And you can see we've got our nice parabola here. And it wants to know the maximum height of the shot and how far from the point of release does it occur. So you're looking for the maximum. So you can click where you think the maximum is, and it'll tell you the values. So the height is 15.2, and it occurs 30 feet. So that's your x, so 30 feet from the point of release. Then it wants to know the shot's maximum horizontal distance. So if you look at the graph, horizontal distance is across the x. So we're looking for where it hits the x-axis over here. It's 68.987, and we're rounding to the nearest tenth, and so that'll round up to 69.0. And then from what height was the shot released? So that's your y-axis, your y-intercept, and it's 6.2. And then our last problem is very, very similar. We're going to type in the function. And let's see, it's plus 7. Okay, so we have our function here. You might want to zoom in a little bit, get a little closer. So again, it wants the maximum height, and where that is located, you can click. It'll tell you the maximum height is 8.6. And it occurs 4 feet from the point of release. And then how far does it travel horizontally before hitting the ground? That's that positive x-intercept again. So 13.3, because it's rounding to the 10th this time. And then it wants to know which graph matches the function. And so you can kind of look, you can zoom in even farther if you want to and see the smaller values on your axes. And so it's hitting somewhere between 5 and 10, and that tells us that it is A. Okay? And that's it. So basically what you're doing is you're graphing the function or the equation each time, and you're either looking for the maximum or the y-intercept or those x-intercepts. And most of the time, as you've noticed in the problems that we're looking at, we're talking about that positive x-intercept. And when there's a negative and a positive, we've been looking at the positive, because most of the time our x-axis is time. And so we don't think about negative time, we just think about positive time, because there's no such thing as negative time. And so that really narrows down even your focus. It narrows it to that positive side of the x-axis. Okay, so I hope that these examples and walking you through the graphs have helped you when you're doing your quadratics test. If you're unsure, you don't know what to do, you can solve by graphing. You can put your equation in and see what your x-intercepts are. If they're real, they'll show up on the x-axis. Now, if they're not whole numbers, that's not going to be super helpful to you because you will have to simplify those radicals in the quadratic formula. But this would be a great way to check your answers and see if you're correct. Okay. If you have any questions, please let me know. Don't hesitate to jump back in the Google Meet, send me an email, hit Ask My Instructor button, whatever you need. Okay. Have a great day, guys.